This video goes along with the PowerPoint included on Canvas for section 3.10, where we're finding the derivative of inverse trig functions. So there are 4 examples given, and I just want to work those 4 examples so you can see where the answers came from. And in front of me I have a couple of things. Obviously the examples written down, but I also have the rules for the inverse trig functions. And so it did say in the PowerPoint that you didn't have to memorize these, so I've got those in front of me. And I'm also going to need to use the unit circle at one point in my work here since we're dealing with trig functions, and so I do also have a unit circle. Now this is something that I obviously have memorized, and you should as well, but I figured it would be a nice visual when I'm referencing it to actually use the unit circle. Alright, so here we go. So in the first one, we are finding the derivative of the inverse sine of x squared minus 1. So I will work through the solution to that particular example. So first of all, I need to know what the rule is for finding the derivative of the inverse of the sine function. So I'm going to write that down. The inverse sine of x, derivative, is 1 over the square root of 1 minus x squared, where x is the argument of the sine function. So in this problem, the argument is more than just x, it's actually x squared minus 1. So when we actually take the derivative here, we are going to need to use not just this rule, but also the chain rule as well. Alright, so I'm going to find the derivative by doing 1 over the square root of 1 minus my argument squared. And in this case I mentioned that our argument is x squared minus 1. And chain rule says I then have to take the derivative of that argument. So if I take the derivative of x squared minus 1, that will be 2x. Cleaning that all up, I can multiply straight across, giving me 2x on the top, and on the bottom I've got 1 minus x squared minus 1 quantity squared. I'm going to take that one step further because what's inside of this square root right here can simplify. So let's do that. So 2x stays on the top. On the bottom I'm going to square out x squared minus 1. And we'll just do a little bit of algebraic manipulation here in order to get to our final answer. So we're going to do 1 minus x to the 4th minus 2x squared plus 1. And then of course let's do that subtraction. So if I do 1 minus x to the 4th plus 2x squared minus 1, it turns out that those 1's actually cancel out. And so we'll have x to the 4th minus 2x squared in that denominator underneath that square root. Okay, so that answer should match what we saw in the PowerPoint. Alright, so let's take a look at the second example. Did a lot of work here that I'm going to try to work around to stay on the same page. So let me scoot this over a little bit. And the second example has us finding the derivative of the cosine of the inverse sine of x. So once again, we have a chain rule that we have to apply. Okay, because we're not just taking the derivative of the cosine of x, we're taking the derivative of the inverse of the cosine of the inverse sine of x. So because of that, we will be using a chain rule once again. Alright, so first thing, we would probably want to figure out what is the derivative of cosine. Okay, so that's what we'll start with. The derivative of cosine is negative sine. Okay, negative sine of the argument, which in this case is inverse sine. And then again, because it's not just x, it's the inverse sine of x, we use that chain rule, and now we take the derivative of the inverse sine. So I'm going to refer to my derivative cheat sheet here, and the derivative of the inverse sine is given by this equation. So I'm going to do 1 over the square root of 1 minus x squared. And in this instance, the argument of this inner piece is just x. So that's what I filled in here, and the derivative of that is 1, so I don't need to do another chain rule. Alright, let's clean this up. So we've got negative sine of the inverse sine of x, and I put that multiplication symbol there, but I don't really need it, dividing by 1 minus, or the square root of 1 minus x squared. So something interesting happens here that hopefully you remember from your trig course. When you take the sine of the inverse sine of x, or in other words, you compose composition of functions, two inverse functions, they actually completely undo each other, and therefore all of this just becomes x. So in other words, if you take the inverse sine of x, and then you take the sine of that, you're just going to get that same x right back out. So negative x on the top, square root of 1 minus x squared on the bottom. And that is our solution to number